be a watershed event when home buyers go to look at their new home and they spend as much time looking at what's in the basement as they do and what's in the granite countertops. Well, we're really pleased to have this panel with us today. Luke is going to serve on the panel as well. We also have Tim Enwall, who's the president and COO of Tendril Networks. John LoPorto, who's the CEO and founder of PowerTagging Technologies. DeBlasio, who's the lab program manager for distributed energy and electric reliability at NREL, and Carl Lawrence, who's the founder and CEO of EEtrex Incorporated, formerly known as Hybrids Plus. So, as a way of getting people warmed up and introducing themselves and what their companies do, I thought I would refer to the parable of the five blind folks that are looking at the elephant, and each one of them thinks that the elephant looks like something else, whether it's a leaf or a trunk or a wall or a snake, because they happen to be touching a different part of the elephant. Well, when I look at our five panelists, I realize that each one of them is touching a different part of the smart grid. So my question to you, and we can go down the line, perhaps we can start with Carl, is what part of the smart grid are you touching? Tell us about your company and explain what it is you do in those terms, and explain how it affects your vision of the smart grid, and perhaps whether that's beneficial to us or maybe it's not.
One question, do you want that slide section now, or?
Do you have slides on here that you want me to? Maria will handle that. She knows where it is.
That sort of answers the question. EEtrex started out building battery systems to convert the Toyota Prius and then the Ford Escape into plug-in vehicles. As we were doing that, we were approached both by...
Doesn't sound like it's working.
All right. We were approached both by XL and the Governor's Energy Office to try to build some V2G technology, vehicle-to-grid technology. And that's actually become a very strong part of our company. So when we look at smart grid from our particular point of view, it is to utilize the vehicles that are going to be out there in the future as part of the smart grid system to make it more efficient. As Luke was talking about, the supply and the demand don't match up. Here's an idealized illustration. The yellow section is solar coming in primarily, noontime. The blue is wind, which would be more early morning or late evening. And then the orange section back there is demand, which would actually be quite a bit larger than what you see there currently. But our vision is that as these build out, you've got enough. You can have enough supply in the future to really have an impact on the demand, that supply coming from the renewable energy. In addition to that, the coal-fired power plants, as Luke was talking about it, they can supply energy to meet all the base loads. It's meeting the peak demand that's a challenge. If there was some way to store the energy from solar, wind, and also the coal-fired power plants, the regular power plants, to use them to meet that demand, time shift them through, that would make the grid much more efficient. So what we see is that in the future there will be millions of electric vehicles out there, thousands of them, millions of them, depending upon what time frame you're looking at. But as an example here, we're looking at possibly putting back, electric school buses out there. An electric school bus would probably be able to store 50 kilowatt hours of electricity, and it would be able to, with our technology, it would be able to feed the power back to the grid at about 12 kilowatts. Chevy Volt is about 16 kilowatt hours of storage, and it could feed the power back to the grid at about 6 kilowatts. So in this little quick analysis here, 7,000 school buses is equal to the power required, or the power coming out of the Comanche power plant down in Pueblo, the new one that just went online. 7,000 school buses is about close to what we have in the Front Range, or 14,000 Chevy Volts. The point is that out of one fleet, you could have a serious impact on the need for additional power plants. Vehicles are parked 95% of the time, some 96% of the time. They're primarily sitting there waiting to be used for some other application. There are other fleets that can make could be part of this also. And so as we look up and down the Front Range, you'll see Postal Service, the delivery services, bakeries, other fleets that will be out there that know their operating schedules for the vehicles, when they'll be available for feeding power back into the grid or storing wind energy at night. By having the storage distributed around the entire network, the need for larger wires is reduced because you can feed the power at a lower rate throughout the grid, and then when it's needed at a higher rate, it's already out dispersed through the grid. What this may be worth, we've seen for just energy storage, we've seen numbers of about $100 to $300 a year for the average vehicle to arbitrage the energy. A recent report from the Postal Service felt that because of the size of their fleet and the time that their fleet is actually being used, if they switch their vehicles to battery powered, they may see as much as $2,300 a year per vehicle. The second part of having the vehicles out on the grid is regulation. Currently, taking care of the grid for sags and voltage or effects on the frequency to maintain the 60 hertz is taken care of by spinning reserve equipment like the blue generator there. And those are left running 24/7 to respond to those minor fluctuations throughout the day. We were told that in the middle of California, these events happen about 300 times per year. 300 times per day. That equipment could be replaced with vehicles, groups of vehicles, fleets of vehicles, having vehicle-to-grid technology in there. And Willett Compton out of the University of Delaware, I believe the report was saying that would be worth between $1,000 and $3,000 a year to the owner of the vehicle used in that situation. So that's our view of the vehicle interfacing with smart grid.
Thank you, Carl. Dick?
My name's Dick DeBlasio, and thank you, Peter, for inviting me to this gathering. Sounds like I'm going to learn something, especially from the business side. But I'm the laboratory program manager for electricity, and I've been at NREL for 32 years since the beginning of this start in 1977. It was called SERI at the time, Solar Energy Research Institute. And if you go to the next photograph, please. That's a picture of our campus, which